Okay, let's look at this example. Candy and Randy have a jar containing 72 coins, all of which are quarters or nickels. Let's just say this. Let's say that Q is going to represent quarters, and N will represent nickels. So one equation we're going to have is for the number of coins. If we take the Q plus the N, when we add those together, we're going to have a total of 72 coins. That's one equation. Next equation is going to be for the amount of money. Now, we know that quarters were 25 cents, so I'm going to use a decimal, 0.25, to represent a quarter. The reason why I'm using the decimal is because the dollar amount is in terms of decimals also. Now, it's 25 cents for each quarter. We don't know how many quarters there are, except for the fact that it's Q, so we'll use 0.25 Q to represent the amount of money in quarters. Now, a nickel is worth 5 cents, and so for each nickel we'll use N. And the grand total of the amount of money from both coins is $13.20. And so we have our two equations that you can solve using different methods. Now let's look at this example. On this example, you'll notice we got 9 miles in 1.5 hours, and the return trip is 3 hours. It involves still water. So we're going to let X represent the rate in still water. And we're told that Y represents the rate of the current. So imagine we got a current. Now if we go up the current, we'll say that's up. That's up current, this is down current. If you go up the current, our Y is going to be a positive Y because it's increasing our speed. So if our rate in still water is X, and up the current means that we're going to be increasing our speed by whatever that rate is. So it's going to be a plus Y. Now if we're going to go down current, let me back up and repeat myself. If we're going up the current, that means we're going against the current. So that's actually going to be subtracting our speed, because the current's going to be working against us. Now if we go down current, that means we're going with the current of the water. So in still water we're at X, but as we go down water we're increasing our speed by whatever that current is, whatever that rate is, X plus Y. And the formula we're going to use is distance equals rate times time. So let's look at down current. We're going to use distance equals rate times time. The distance in either direction is 9 miles. Now the rate is X plus Y for down current, because we're speeding up. And down current, it took us how long? 1.5 hours. It should be a faster trip, because we're going with the current and speeding it up. Now if we go up current, still using distance equals rate times time, same distance as 9. The rate this time is X minus Y, because the rate is working against us. The rate of the current is. And therefore it's going to take us longer. In fact, it takes us 3 hours according to the problem. And so our two equations for our system are 9 equals X plus Y times 1.5, and 9 equals X minus Y times 3. And just a little heads up here, to solve this system, the first thing you really want to do in this first equation is divide both sides by 1.5. And here, on the second one, you want to divide both of them by 3. It's going to make your life a whole lot easier. Now let's look at this example. This one I'm actually not going to use a system of equations. I'm going to just use an equation all at once. We got two towns that are 1,100 miles apart. Miles apart. A group of hikers start from each town and walk the trail towards each other. After 200 hours, they each went 200 hours. They meet up. One group, we don't know how fast they went, so we're going to call that one X. Other group says they went a half mile per hour faster, so that's going to be X plus 1/2. So here's what I would do. We're still going to use distance equals rate times time. But the total distance that the both groups went was 1,100 miles, because A went that way and B went that way. And the total trip combined was 1,100 miles. Now we're going to use the rate times the time. X represents the rate of group A, and then X plus 1/2 represents group B's rate. So what that means is that the distance that group A went for using rate times time is X times 200, or 200X, and then the distance that B went is 200 times X plus 1/2. So if I take the distance that A traveled and the distance that B traveled and add those two together, it gives us a grand total of 1,100. Well, that's our equation. 1,100 equals 200x plus 200 times x plus 1/2, and solve from there. And that's the approach I would take. As always, if you have any questions, just let me know.